Hi, I'm Dr. Bill Cordua. I'm a geology professor associated with the University of Wisconsin River Falls. In this program, I want to talk to you about rivers and streams, which are so central to the beauty of our area. You can learn a lot of interesting geology by looking at rivers and streams. We're going to illustrate this by exploring the South Fork of the Kinnickinnic River, which flows through River Falls, Wisconsin, for a distance of about 7 miles from its headwaters to its mouth, descending about 250 feet. Even though it's a small river, it illustrates many of the ways rivers work and how we interact with them. The South Fork also has significant biological resources. The DNR classifies it as a Class II trout stream. This good water quality is due in large part to the lack of development along its course. Right now I'm standing at the headwaters of one of the tributaries that come together to form the South Fork. When you have groundwater seepage and you have runoff from the surrounding hills, they'll gather together, such as you see in this pond behind me, held behind a little retaining dam there. The other side of the hills, we are on the divide where water flowing will flow into the Trimble River. But right here, the water will flow down and feed the South Fork. Downhill from the dam, you can trace the small valley where the South Fork gathers water from the surrounding hills. This is the birthplace of a river. We're a few miles downstream on DNR land, not far from Highway 29. The South Fork will grow in volume as various tributaries join to it, like the one you see right here. This tributary is draining all these hills in the background, and that's all part of the South Fork's watershed. It's spring now, so these tributaries have water in them, but later in the summer they will be dry, and in that time the South Fork will have to rely on groundwater springs for its water source. The flat area I'm standing on is part of the South Fork's floodplain. Floodplain refers to this relatively flat area adjacent to a river, and as the name suggests, it's very prone to flooding. FEMA runs the National Flood Insurance Program, which provides protection to people who live in areas that could be affected by a 100-year flood. That is, in areas that have a 1% chance of being flooded in any particular year. Of course, as the climate modifies, FEMA also has to modify its floodplain maps to keep it current with the current regime of river flow. But flooding is not what forms floodplains. Floodplains are really formed by the movement of meanders. Meanders are bends in the river. And there's an excellent example right behind me there, where you see the water come around and cut back on itself. Meanders have several important parts, which we'll look at more closely next. Getting a little bit closer to this meander, meanders generally have two parts. The part that's on the inside of the bend forms a deposit we usually call the point bar. Point bar is not too visible here, but I think maybe you can see the river current a little slower on the inside of the bend. On the outside of the bend, we have a feature called the cut bank. The cut bank is where the river current is flowing a little faster, and thus it's a side where we generally have erosion, where the river will cut into its floodplain. The DNR has done a lot of remediation along the river here, including putting down hard rocks to keep the meander in place and also to keep silt and sand from accumulating in the river. But if the river was left to do its own thing, you might say, this river would cause its channel to shift slowly in a particular direction indicated by the meanders. So the river channel would cut my way, fill in from the opposite side, and slowly move this direction. As it fills and cuts, it produces a flat surface, and that surface eventually will become the floodplain. We can see this process well from the air. This is an air photo taken of the Trimble River, not far from where it empties into the Mississippi. The point bars and cut banks are easily visible, as is the floodplain. If you look at the meander at the bottom of the screen, the river will be shifting toward the left, with the cut bank side on the left and the point bar side on the right. Eventually, meanders get so extended that the river will cut through to straighten its course. When that happens, the old meander is left stranded. If it contains water, it's a feature called an oxbow lake. If it's dry, it's a feature we call a meander scar. This is an air view of the Jefferson River in Montana. You can see numerous meander scars and oxbow lakes. It's clear that this river has moved back and forth across its floodplain over time. Small meander scars also occur along the South Fork, as we'll see a little further downstream. I'm under the Highway 65 bridge where it crosses the South Fork right on the east side of River Falls. And I'm on the point bar of a little meander here, and that side of the river is the cut bank, and you can see how they've armored the underside of the bridge. Those bales of rock are called gabions, and they're put there to cut down on erosion so that the point bar does not shift too far this way and undercut the bridge. Wherever you cross a river with a structure, you have to worry about what that river is going to do over time, because its channel is going to shift on you. Here's a good place where we can see the various kinds of sediment that the river is carrying. Rivers carry sediment in three different ways. We have what's called the bed load, which is the material down on the bottom of the river, and that generally moves only during floods when it bounces along the bottom. We also have suspended load, which is what you see if the water is very, very muddy. Since the water has been sort of calm today, most of that material has settled out, but again, with the water velocity increases, it'll be picked up too. The third type of load is the dissolved load, which are the invisible chemicals that this water is carrying. This is probably, in this area, probably mostly calcium and magnesium, which is getting from weathering of the surrounding rocks. You can find all this type of sediment if you look on the sediments in the floodplain. You just dig around in there and you'll find lots of nicely washed sand and gravel. That's the product of the river having moved back and forth as it made its floodplain surface. I'm on the UW River Falls campus and standing in an old meander scar. When I first came to River Falls in the early 1970s, the river actually flowed through this channel here, and this was part of the meander with the cut bank behind me. But then one year there was a very large rainstorm, and this river cut a new channel over in that direction, which is where the river is today. So between one day and the next, this channel had become abandoned. This meander scar is now filling in with sediment and will eventually become part of the normal floodplain of the South Fork River. Well, I'm on the UW River Falls campus, not far from the University Center, and this is one of the storm drains that drains part of the city of River Falls. So when you see water during a heavy rain or snow melt go down the drain, it comes out in a place like this. This water is not treated. It doesn't go through the sewage treatment plant. It comes straight through here off the street and right down this little tributary into the South Fork. For that reason, it's very important to watch the sort of things you put on your lawn or spill in your driveway or dump on the street, because whatever you do is going to come right smack into the river without being treated. You don't see much water right now, but during a very heavy storm, this thing could be filled up to over my head. So it's pretty impressive the amount of water that can come off of our city streets. We're near the amphitheater on the UW River Falls campus, where many people enjoy wonderful free concerts all summer long. Near the amphitheater, we have this little bridge. And bridges like this can be a real pain in the neck going across streams. You see along the sides of the bridges, you see the rocky riprap and the concrete poured there. That's because this bridge has been undercut at least 3 times since I came to campus and had to be replaced each time. Again, the river here is constrained a little bit by having to come through the opening, and so it tends to erode on both sides of the bridges, some side a little bit worse than the other. So this is a constant source of additional work for the maintenance crew down here on campus. Behind me we see a little pond that's used to capture rainwater that comes off the campus streets and parking lots. There's several reasons for having a structure like this, not just to breed mosquitoes, but also it helps for sediment to settle out in a pond like this before it gets into the river. Also, if it's a very hot day and you have a summer thunderstorm, a lot of water will come into the South Fork very fast and can be quite warm, which will give a thermal shock to the water. By having the water trapped in little ponds like this, that water gets to equilibrate a little bit in temperature before it moves on into the stream. That also allows this water to soak in instead of flowing directly into the river, and this will go underground through the little pores within the sediment here. In fact, floodplains can be looked at as great big sponges, and so the pores are water filled. In fact, the time of year when you have a high water table, you can actually feel the water as you bounce around on the surface of the floodplain. So this is a reservoir of water really that feeds this river during the hot summer when we don't have much rainfall. This little station behind me is one of the places where the university and the Wisconsin DNR collect important data on groundwater flow as well as on flow characteristics of the South Fork. There's about 4 stations in campus to measure water flow in the river, what we call discharge. There's also about 20 monitoring wells that look at groundwater quality of the water that seeps into the river. UWRF students make use of this data in a lot of their research projects. Here are a couple of River Falls students getting their feet wet collecting data along the South Fork. They measure such things as channel shape, sediment flow, water flow, pH, temperature, and many other variables. We're behind the Ag Engineering wing of the Agricultural Science Building on UW River Falls campus. To this side of me we have the South Fork, which is making a beautiful meander bend here. When this campus building was built, this meander created a significant problem that had to be solved with riprap, as you'll see in the next set of photographs. In 1980, the cut bank of the South Fork was rapidly moving toward the building. You can see utility pipes are undercut and the building itself would be at some risk during a flood. The campus regraded the channel and armored the cut bank with slabs of rocky riprap from a nearby quarry in order to slow down the river flow. In this photo, it looks like a bit of an overkill, but you need to come back during a spring rain event. Here's the flood in 1989 when we can see the riprap doing its job. Notice the fast and slow current areas where the point bars and cut banks will be forming. By 1996, vegetation had grown up and was helping to hold the riprap in place. This river has now been held in check for over 30 years. This riprap has done its work well. We're on the west end of campus where the South Fork drainage begins to look very different. Upstream from me, the river is moving down a very broad, wide valley, very gentle gradient as it comes down. But from here on down, all the way to its mouth in Glen Park, the river becomes very gorge-like. So what's the reason for that? Well, it's very simple. About this point, the river starts to encounter very different bedrock. Upstream, the river is cutting through very soft sands of the St. Peter Formation, and that's very easy for it to erode a nice wide valley for the meanders to go back and forth across it. But from here on down, this becomes very tough bedrock, and it's very hard for the river to make a wide valley. It has to expend most of its energy cutting downward, and that is what creates the gorge that we see going through the western part of River Falls. We're by the waterfalls in Glen Park in downtown River Falls. The Glen is a favorite place for people to come for picnics or on summer afternoons to enjoy the waterfall, the cool breezes, and the beautiful vegetation and flowers that grow all around this glen. These waterfalls are the reason the River Falls got its name and are an important part of our community's heritage. If you look closely at the falls, you'll see the hard layers of dolostone and limestone that the river is coming over. Those hard layers are not very easy for that river to erode, so it leaves them behind as ledges, and that forms the waterfalls which give the city of River Falls its name. The bedrock is not all equally hard, and you can see places that there are recesses or alcoves in the cliff face where the river has encountered softer rocks. This undercuts the cliffs, which allow these large rocks to break loose and fall down periodically into the valley. A dam and mill existed here for many years. Narrow gorges are favorite places to capture the water power for grinding grain or sawing logs. This dam has long since washed away and the river has regained its natural grade. Well, we've reached the end of the South Fork where it drains into the Kinnickinnic River. The Kinnickinnic River forms the base level for the South Fork, which is the elevation of the body of water into which a river flows. When a river gets to its base level, it tends to lose a lot of its energy. Hence drops out most of its suspended and bed load, forming a deposit like this. This is called a delta, a very nice delta at the end of the South Fork that constitutes the remains of all the material that it's been eroding through in its long journey down here. Many locals are familiar with the delta where the Kinnickinnic River drains into the St. Croix River, although they call it the sandbar rather than the delta it really is. The skewed shape of this delta reflects the influence of the St. Croix current, remobilizing the sediment and washing it further downstream. The features described in this program are not unique to the South Fork, but can be found along any river, big or small. You might find it quite enjoyable to walk along your favorite river and see how many of the features described in this program you can spot.